Hello, today is sort of review, sort of preparing for more complicated factoring we'll be doing next week. So we're expanding and factoring polynomials. I'm going to show you, there's a ton of them, a few from each section, okay, and we'll see how that goes. And by we'll see, I mean I'll decide as I go because you guys can't respond to me since it's a pre-recorded video. All right, so this first part, find each product. Well, we can distribute. So let's do like number 3, we can do 2r times 6r, which is 12r squared, 2r times -7, -14r. If we look at number 6, 8n squared times 2n squared is 16n to the 4th. 8n squared times -3n is -24n cubed. 8n squared times 6 is 48n squared, and the rest are similar. So next part, we're factoring the common factor out of each expression. We usually call this GCF. So if we look at number 7, in terms of numbers for 12 and 54, the greatest we can take out is 6. For the n's, the greatest we can take out is an n squared. And 6n squared times 2n squared equals 12n to the 4th, and 6n squared times 9 equals 54n squared. Looking at number 10, let's think of numbers first. 9, 24, and -21, I can take out a 3. In terms of, let's see, I always like to put x first. We can't take out any x's though. In terms of y's, we can take a single y out of every term. So 3 times 3 is 9, y times y is y squared, and then we have an x cubed, okay? So 3y times 3yx cubed equals 9y squared x cubed. It's kind of a mouthful to say. All right, so 3 times 8 is 24, y times y squared is 8x, I'm sorry, y times y squared is y cubed. 3 times -7 is 21, y times 1 is y. And so really here, now let's multiply to make sure we were right? Like 3y times 3yx cubed is 9y squared x cubed. Good. 3y times 8y squared is 24y cubed. Good. 3y times -7 is -21y. Now we'll do a couple of these. Find each product. And it's kind of implied, even though it doesn't say. Once you do, you should always simplify. You should really always simplify no matter what. It's just a good practice to get into. So if we look at number 11, 3n times 8n, 24n squared, 3n times 5, 15n, -2 times 8n, -16n, -2 times 5, -10. So we have 24n squared, 15 minus 16 is -1, or just -n, minus 10. So distributing that way is fine. If you like to use like a box, you can do that too. Let's look at 16. So we have 2 variables in here where the process is exactly the same. If we do this with a box, we can put 5u and plus 7b. And when it's plus, we don't need a sign at all, right? 5u plus 8v. If we had a minus anywhere, that would just go in front of the second term. 5u times 5u is 25u squared. 5u times 7b is 35uv. 8v times 5u is 40. You could say vu, but I'm going to stick with uv. 8v times 7v is 56v squared. So then our answer is 25u squared. 40 plus 35 is 75uv plus 56v squared. And these are all very similar. And the last piece is factoring. There's tons of them. The first thing you always want to check for is a GCF, and if you don't have one, you factor from there. So when a equals 1, like number 19 here, meaning the squared term has no coefficient, which is basically just a 1, we can factor by shortcutting and say what adds to be -4 and what multiplies to be negative 21. And so we know it's an R and an R. And so I think 7 and 3, so to add to be negative 4, I have to do a negative 7 and a positive 3. And then negative 7 plus 3 is negative 4. Negative 7 times 3 is negative 21. All the ones with a equaling 1 are the same. I'll show you, you know what, I'm going to leave that. I'll show you two of the other kind. Let's see. It looks like, let's do 24. So I'm going to show you guess and check, and then I'll review Xbox if you like to use that. So we have a 7n and an n. Those are the only terms that multiply to be 7n squared, because 7 is prime. I know the numbers have to be multiplied to be 16, and so if I think of that, I mean I have 16 and 1, and obviously we'll have to deal with the negative piece, but for now let's just think of general factors. 16 and 1, 4 and 4, 8 and 2. And so now we can really just kind of guess. So what if we did minus 4 plus 4? 7n squared minus 28n plus 4n. It's not going to quite work, right? So the 4's don't seem good. Let's try 8 and 2. So what if we did plus 2 minus 8? 7n squared plus 14n. Actually, you know what? We need two negative, right? Because they have to multiply to be positive 16. So 7n squared minus 14n minus 8n plus 16. 14 plus 8 is 22. So that's it. So that will always work. If you prefer, you can do Xbox. So I'll show you one of those. So let's do Xbox for number 28. So for Xbox, first you make, your X, then you make your box, right? So here A is 10, B is negative 19, and C is 6. And up here we put ACX squared, and down here we put BX. So 10 times 6 is 60, so we put 60x squared up here. B is negative 19. So we're looking for what multiplies to be 60 and adds to be negative 19. And so that's going to be negative 15x and negative 4x. So then we can make our box. And so on the inside, so we'll put 10x squared, and we'll put our 6. The goal here was that we split up our negative 19x into negative 4x and negative 15x. And now we can find the GCF of each row and column. So GCF of 10x squared and negative 15x is 5x. I'm going to keep it positive because in general you want, the first term of your binomials, to be positive because it looks nicer, honestly. Negative 4x and 6, I'm going to go for negative 2. 10x squared and negative 4x, 2x, negative 15x and 6. Let's try negative 3. And so truly, I kind of guess on the negatives. It's always good to check at the end and make sure you did it right. So 2x times 5x is 10x squared, good. 2x times negative 2 is negative 4x. Negative 3 times 5x, negative 15x. Negative 3 times negative 2 is 6. So we're good. So then our factored form is 5x minus 2 times 2x minus 3. Let's see. I'll show you one more, I think, with Xbox. And remember to watch for a GCF just in case. Oh, actually, you know what? I'm going to show you this one too. So if we look at 33, for example. Here, factoring completely, sometimes when you only have two terms, you do need to just take out a GCF, and that's often all you can do. So we can take a 3k, and 3k times 3k is 9k squared plus 4. So sometimes that's as far as you can go. But let's do one more Xbox with, you know what? Let's do 37. These numbers look big. Ew. And because of that, I want to look for a GCF. So 30, 125, 70, they all end in a 5 or a 0. They must be divisible by 5, right? So if we take out a 5, we have 6x squared minus 25x plus 14. That looks a little more doable. So let's do Xbox with this. 6 times 14, which is 84, x squared, negative 25x. So now we want to know what multiplies to be 84, adds to be negative 25. It's going to be negative 21 and negative 4x. So now we make our box. Help if I could draw lines down the middle instead of towards the side. Oh, no, now I went towards the other side. I don't know why it matters, but we'll leave it. And so then we put 6x squared here, 14 here, and then we split our negative 25 into negative 21x, negative 4x. So our GCF of 6x squared and negative 4x is 2x. Negative 21x and 14 is going to be negative 7. 6x squared and negative 21x is going to be 3x. Negative 4x and 14, negative 2. Let's check them, okay? It looks like 3x times 2x, yep, 6x squared. 3x times negative 7, negative 21x. Negative 2 times 2x, negative 4x. Negative 2 times negative 7 is 14. Good. And so now our final answer, we have to keep our 5 because it's still there, it's just on the outside. So we have 5 times 3x minus 2 times 2x minus 7, and that's our final answer. Complete the rest of these on your own. The key is attached at the end of the document. It's just the answers.